Hello again, this is Angelos from Elite PvP recording tutorial 3 part 2 of the tutorial series Let's Make a Memory-Based Bot. Alrighty, now in the last tutorial we went into the process of finding the send function, we found it, and now we're in the process of hooking that function. Now in this tutorial we're going to do three things. We're going to hook the function so it's being called in our DLL and we have access to the packets. 2, we're going to see how to call the send packet function from our DLL. 3, we are going to see how to find the function programmatically without us going through all the debug and finding it every time. Now the thing is, every couple patches, once in a while, the assembly code inside calculator.exe changes, and we're going to have to go through this process of finding the function again and finding the newly added assembly code or the assembly code that had changed in order to find our function. So that's not an issue because it doesn't really happen very often, and when it happens, you'll have all the information you need to find that function again. So let's get started, and the first thing we're going to do is I have Ole open right here, and I'm right inside that function that we found the last time, and we said that this is a very convenient place to place our hook. Now I'm going to switch back to our project folder right here, and I'm going to the CB helper. Remember the bot project which we created in tutorial 2. If you haven't watched that video, go ahead and watch it. Now I'm going to open CB helper and I'm going to open the project. Alright, now there's a couple of things, actually a couple of silly mistakes that I've made, and we need to change those stuff so we don't have any problems in the future. Now let's do that now. First thing, I'm going to go to asm.cpp. Now this is never mind what it is, we'll explain these functions later. Now the mistake that I've made is that I made these functions static, but I didn't tell this document here where those functions are defined. So if I try and use it somewhere else in the project, it'll give me an error. It's not even going to see these functions. So I'm going to open the header files. I'm going to open basic stuff, and then I'm going to open asm.h. Now if you look in here, I tried to document stuff as like the best I can. I don't really know if that's going to make it easier to understand or maybe make it more complicated, but I did my best, and it's very time consuming, so I'm not going to do everything. I'm sorry. Anyway, now we're going to change this first thing into static. That's a mistake I made. The other mistake I made is in asm.cpp right here. We need to change these to the following. I'm going to right behind this, the function name, the void name, I'm going to type asm, whatever those two dots you call them, hit shift and the two dots. I don't even know what you call them in English. So I'm going to copy this, what I just added, and I'm going to paste it right after every void name. Right here, 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 and here. Okay, with that done, let's build the project. It should work just fine. Now, it doesn't matter whether you're using Visual Studio 2010 or 2012. It'll be the same for you, except you won't see these beautiful colors in your project. Anyway, so if you're using Visual Studio 2010, do the same steps. Everything that you see me doing, you can do the same. And if something doesn't work, just let me know and I'll try and fix it and help you fix it. Anyway, with that done, let's close this. Or before we close it, actually, let's go back to asm.cpp, and we're going to find the function that said extract address, and we're going to remove the part where it says reverse at. Now, I was going to use this for a total different purpose, but now I'm just going to use it for this purpose. And I'm going to remove this line here where it says reverse rated reverse at. Just remove this, and the void underneath it where it says find pattern, I'm going to open this, and I'm going to find where it says return PTR, which is shortened for pointer. I'm going to type -1. I've tested these functions, and I should have done that before I uploaded the project, but unfortunately I didn't. I was just too lazy to do that. Now that I've tested these, I know they're not really functioning the way they're supposed to. So with that done, it should work just fine. Now build the project again. With that done, I'm going to close these two documents, and the first thing I'm going to do is let's see. Yes, I'm going to find that function. So the first thing we're going to do, like I said, we're not going to go every time and find the function manually. We want the program itself to find it. So to do that, let's switch back to Ole. Open Ole debug and find this function. If you didn't, all you got to do is just find this address here. Or if you remember, we placed the hardware breakpoint on it. The hardware breakpoint will never go away. It'll be there as long as you don't delete your UDD files. So all you gotta do, open Ole debug, file, open, and you can open it from here, or just go open and open conquer.exe, the same one that you opened last time, and go to view hardware breakpoints, and it'll show that breakpoint. Double click on it, it'll be there. If not, just follow it, find it using this address. Now, to find this function here, or this call specifically, what I'm going to do is I'm going to search the process memory for a certain number of bytes. Now, these instructions here, those, let's say these 4 lines, those 4 instructions are an assembly instructions. Now, if we want to convert them to binary code, the binary code for these functions is right next to it, this column here. This is the binary code for each instruction. Okay. Now, if this is the binary code, then I can basically copy the binary code for this instruction and search for these instructions in memory. So if I highlight these right here, 4 lines, right click, edit, binary copy. Now, if I open a notepad and paste what I just copied, all I get is these bytes. Now, let's compare these bytes to this column here. I have 8D4604, 8D4604. So each two numbers of these numbers represent a byte. So if I were to search the memory now, I'll be looking for 2468 bytes. So I'm going to be searching the memory for 8 bytes that are equals to these 8 bytes. Now remember, every time you search in the memory for a certain number of bytes, a certain buffer, let's say, of bytes, it might occur anywhere. Like these 4 lines, these 4 instructions could be located anywhere else in this process, and they could occur so many times, not just once. So the same 4 lines could be used in a different function, and when you search, you can't really tell which is which, and it might find, let's say, edit binary copy, and I'm going to go up here and pretend that these lines here, I'm going to edit paste. Pretend that these lines here are already there. we didn't just add them. So if I have to search the memory and start at this address here and tell it to end the search at this address here, it'll find the first occurrence for these 8 bytes for the 8 bytes that we just copied is here. So it finds that these are the first 4 bytes and it stops searching. So now that we know that, we need to make sure that the range of the addresses that we give the program to search doesn't contain more than one specific pattern of code. So I'm going to edit, undo selection. So I've already done my homework, and I know that these 4 lines almost don't almost not used in anywhere in this program except here. So what I'm going to do is I'm going to right click, edit, binary copy, and I'm going to paste them here like we did, and I'm going to save them. Now I have this document here and I can save it, but I'm not going to do that. I'm going to switch back to our DLL project, and I'm going to create a class. Now you don't have to do what I'm doing. You can do it your own way, but I'll just do it my own way. I'm going to create a class, and I'm going to call this class properties. Yes, I'm sure that's how it's spelled. Okay, in this class, I'm going to leave the public keyword, and I'm going to delete these 2. In this class, I'm going to type the following: static int, and this class, the properties, basically we're just going to save stuff that we need to use anywhere in the project. So all we gotta do is just include this class and use these variables that we're going to define in this class. So this variable is going to be called one second, yeah, I'm going to call it network class. Okay, network class. What is the network class? If we switch back to Ole, excuse me, this is the network class. This is the opposite of the network class, and what I'm going to do is I'm going to right click on it, and I'm going to follow and dump immediate constant. And as you can see, right here, this value here, 9AFBF8, this is just empty. I don't even know what the fuck is that, but it doesn't matter. We'll just do what the program is doing. So it moves the offset of this value into ECX, and then it continues. Now this is going to be our network class. So to find this programmatically, we're just going to switch back, and we're going to save it here once we find it. But what do we do to find it? Now that we defined this, let's copy this, switch back to probably to CPP, and we're going to type okay, properties. Okay, that way. So, and it's going to equal 0. Okay, let's close this class for now. Save it, close this, save it. Okay, now to find this, I'm going to go to the source files, basic stuff, basic stuff, and I'm going to open the CB helper. Now, in this class, I'm going to remove all of this, all these 4 includes, and I'm going to leave the basic function. Now, underneath this, I'm going to type include, and I'm going to include the asm.h. Now, I'm going to type in here, I'm going to start finding my function. Now, what I'm going to do, I'm going to search for the bytes that we just copied, these bytes, which represent, let me copy this so it's clear for you. Edit, before I edit and copy. Yes. And I'm going to edit, copy as table, and I'm going to paste it here. Now, uh, those bytes in top of this document represents these instructions. What did I just delete? Okay. This is annoying. Okay. These bytes represents these instructions. So that's what we're going to be looking for. So let's switch back to our project, and I'm going to type unsigned. Is that how you type unsigned? Yeah, right. And it's going to be char, and it's going to be called send packet bytes, and it's going to equals those bytes. So copy these bytes that we just copied, paste it here, and we gotta make it C++ friendly. So let's do that real quick. 0x, I'll just copy this. It'll be easier. Okay, paste it. Make sure you don't lose any of these numbers. That's important. And these bytes are this is what the program is going to look for every time it searches for the send function. So underneath this line, I'm going to type ASM find pattern, and right here it's asking me for the start address and the end address. Start address and the end address are where to start the search and where to end the search. So I'm going to switch back to Ole. Now I know, let's put these back to the default columns. Now I know that this function, this call right here, this is the address of this call. So basically, if I scroll all the way up, like not all the way, like in a good number of bytes. Now this address here is 648693. Let's go back. Let's just copy this. Edit. I'm going to copy the address. I'm going to go back to this document, and I'm going to paste it. Assume this is the start address for our function, the search function. I'm going to hardware breakpoints. I'm going to find this back. Now, if I edit copy address, oh shit, and I'm going to paste it here, you can see the difference between this number and this number now, and how it increased dramatically just by scrolling up and down. This address never occurs twice, like the memory address. It never occurs twice in the same place or in the same process. So now that we know that, if I start the search by this address and end it at this address, any specific bytes of code between these two addresses will be searched. So now that I know that, why don't I scroll down underneath this function, and I'm going to scroll like a good amount of bytes to edit, and I'm going to copy the address, and I'm going to paste it here. Now you can do your homework on these addresses and see the difference between the two addresses and how many bytes the program will search, and the bigger the number or the difference between the start and the end address, the longer the program will be searching. So let's keep those numbers for now and use them. I'll use this as the start address, which is above our function, and I'm going to paste it here, make it C++ friendly, and I'm going to copy this address as the end address, and I'm going to paste it here. Now it's asking me for the bytes that I want to search for. So we'll pass the send packet bytes, and here it's asking me for the length of the bytes. Right now we have 8 bytes, so I'm going to type 8. What this function will do is basically it'll search for the address or the first occurrence for these bytes, which in our case should be the very first byte of the very first 8 bytes that the very first byte of the 8 bytes that we gave it, which is 6A6170. That's what we should get in return from that function. and I'm going to type int send packet address equals, because this function returns an int value, integer. So now that we've done that, if this function succeeds, it'll return a certain address. Let's print this address to the screen to make sure that we found our address. Now I'm going to copy this, paste it, and I'm going to convert it to hex, and I'm going to type or print this send packet address. Now if I build this, it should find our address or our thing. Now if you remember, we changed the output of this project output directory to G, but we did that in tutorial 2. If you didn't, go ahead and watch that part. Now let's go to that folder and start our bot and new client. Now if I look at this screen here, at the console screen, it says send packet address 6E617D. So if I switch back to Ole and keep that console on top, if you look at the address here, 6E617D. So it found the exact 8 bytes, and that was the first occurrence for these bytes, which is cool. Let's close this for now. Now I found these 8 bytes, and this is the start address of these 8 bytes. So if I count this is the start address. If I add 8 to it, it'll be 6E6185. So what we're going to do is save this network class and save this call address so we can call them inside our process, not in here inside our DLL. So to do that, this is the first the address where we found these bytes. Now if we count these until here, that's 8 bytes. 2, 4, 5, 6, 7, 8. These are 8 bytes. Now to get this address here, which is 9A FB F8, I'm going to add another byte, which is the B9, stands for move to ECX, and that will make the count 9. So I'm going to go back to my program here, and I'm going to tell it to do the following. I'm going to type properties. I don't even know how to spell that. Yeah, that's because it's not included. Let's include properties.h. Yes. Okay, now type properties network class equals ASM, please, extract address. That's what we're going to do. We're going to extract the address at. We're going to give it the current address and the destination address. So the destination address in this function, the destination address stands for the last byte for the instruction. So we need to give it the last byte before the last 4 bytes that we want to extract. So if I look at this right here, it says FE 9A FB F8, but if I look in here, it's backwards. So I want to read that the correct way, and I want to save it somewhere. So let's do that now. Actually, let's not do that for this. Let's ignore the extract address function for now, and I'm going to, before this, I'm going to do the following. I'm going to go all the way to the top of the document, and I'm going to include byte buffer. So I'm going to type byte buffer equals, or not equals, just, and I'm going to give it the send packet address that we just found, and it's going to stand for LP void, and I'm going to give it the length of this buffer, which is going to be 4. Now this, when the byte buffer is initialized, it's just going to read 4 bytes starting from this address here. But this address right now points to this address. So I'm going to add 9 bytes, so it reads these 4 bytes. So I'm going to go here and I'm going to type +9. This will read those 4 bytes. Okay, that should work. Now, once it reads the 4 bytes, the network class equals buffer dot read uint32, and the address, the offset is going to be 0 because our value, our buffer is only 4 bytes. So with that done, let's print the network class to the screen and see if that worked. Okay, let's build a project. 1 second. This is not right. That's the right way. Yes. Okay, now build our project, and we're going to switch back to the bud folder. Never mind this, I'm just going to start it from here. And our network class equals 9AFBF8. So let's switch back to OLE and compare them. So move this a little. 9AFBF8. That's the exact network class. So let's close this, which that's cool for now. One last thing we need to do is to extract this address here. So if you look closely, this address here is just written backwards here, which is not an issue, but this address here, look at it, 6E60BC. But if you look at its assembly code, its binary code, it's 2DFFFFFF. It's also backwards, so we read it this way, from the right to the left. Now we need to extract this address. How do we do that? Now I made it a little bit easy in the program, and all I gotta do is basically we added 9 bytes starting from this address here to read this address here. Now we need to add another 4 bytes to the 9, which will give us 13 byte, and the E8 for the call instruction, that's 14 byte. So 14 byte, and then we can read these 4 bytes starting from this address. Let's switch back to our DLL, and what we're going to do is the following. We're going to type this. Actually, let's go back to the properties class. Where did it go? There it is. And we're going to define another value, which is int, and we're going to call this send packet original address. Yes, address equals 0. Now, the reason I did this is because we want to save this address somewhere so we can call it later on. So I'm going to open properties.h, and I'm going to paste this. Make sure it's static, and make sure it's not assigned inside the .h because it will not allow you to assign it. And let's make this understand that it's defined in the .h file. Now we can close this. Now, right here, what I'm going to type properties, yes, dot send packet original address equals. Now I'm going to type ASM extract address. Now we're going to use the extract address function, and like I said, we have to add 14 bytes starting from this address to start reading that those 4 bytes. Now this function is asking for the current address and the destination address. So the current address will be the, the sent packet address plus 13, not 14, 13, and the destination address will be the sent packet address plus 14. Now, how do that work? Let's go back here. I'm finding a lot of trouble explaining this. I'm sorry, you gotta excuse me. I'm just doing my best here. So, I'm starting to have second thoughts about these tutorials. I'm not really doing it good, so whatever. Anyway, now, starting from this address, which is 6E617D, I counted 14 bytes. If I count 14 bytes, I'm going to end up here, at this, right where the breakpoint is placed. But if I count 13, I'm going to end up here, right at these 2 zeros here. So, why did I do that? I did that because I need this address here, and I need to add 1 to it so I can read these 4 bytes. So, I can either go back here. I can either tell it to add 13 bytes, which is going to be the current address, and then add another 14 bytes, where we're going to start reading the bytes, or I can simply create a different function that will be more like will be easier to use. But I'll just go with this for now, and you can create your own functions. And I'm sure once you get the idea, it's going to be like very easy to understand and very easy to implement. So if I build this now and print also to this screen the sent packet original address, it should all work just fine. So let's try that now. I'm going to go back here and I'm going to start Ole. Now, switch back to the console screen, switch back to Ole and then the console screen. Now, if I look here, the sent packet address is this address right here, which is the very first byte of these bytes that we were looking for, the 8 bytes here. That's 4 lines. And it's 6E617D, so perfectly it found that address just fine. Now the network class is 9AFBF8. We also got that right. And the sent packet original address 6E60BC. We also got this address right. So that's perfect. Now let's close this. Go back to our program. Now that we found this, this looks cool, but we haven't made sure that if an error occurs here, nothing goes wrong and the program never crashes. So you need to make sure that you do that before you continue executing your functions. So if no return address here, basically this function, the find pattern, it'll either return -1 here. It'll return -1, or it's going to return the pointer to that function. So if we go right here, if we didn't find a sent packet address, we should return, right? So basically, no return address, I'm just going to terminate the process or print a message or something. So I can do that right here inside those 2 brackets. So if not, do something. And the first thing I'm going to do is I'm going to return false. So the program terminates. If you don't want to terminate the process, I mean the DLL, if you return false, the load library function will fail. But it's up to you actually, really, whatever you want to do. Terminate the process, call exit. The exit function is just going to kill the whole process. You can do that too. Or you can print a message that it failed to find this address, and then if once you see the message, you can go back and check those 8 bytes and whether they changed or not. Okay, now that we've done this and everything worked just fine as intended, what we're going to do is now, how do we call the send packet function inside our process? Now, basically, the whole send packet function thing is these bytes here: ECX, push ECX, push EAX, move ECX, the opposite of network class, and then call the function, and then pop ECI return. That doesn't matter. These 4 lines is what we're interested in. So, how do we call it? We're going to go back to the we're going to open the client.h, which is inside header files. Okay, and then we're going to make the function that will call it. So now that we know the function takes 2 arguments, the length and the and a pointer to the buffer. So what we're going to do is create a function that will take those arguments. So I'm going to type void, and I'm going to call it send packet. I'm going to probably no, I'm just going to call it send to server. Yes, that's more like it. And it's going to take a char array as a buffer, and it's going to take an int as a length. Now I'm going to copy this line, and I'm going to go back to and I'm going to open cbclient.cpp, and I'm going to scroll down a little, and I'm going to paste this, tell it where it's defined. It's defined in cb client, paste this here, and I'm going to make sure it's a naked void. So I'm sorry, yeah, that's one thing we gotta do. Before we do this, we're going to do one more thing. I'm going to open header files, basic stuff, and I'm going to open basic functions.h, and I'm going to define something. Right now, type exactly what I type. Type this square sign and type define, and then we're going to call it naked, and type exactly precisely what I say. Underscore underscore DECLSPEC. Now, if you don't know what the naked word means and does, or even this whole nonsense here, you can Google it. It'll tell you what that crap is. And inside these 2 brackets is going to be called naked. Now, again, you really need to Google this if you don't know what that means. Now, I'm going to close this, and I'm going to make sure this void has the keyword that we just defined, which is the naked. Now, inside this, I'm going to call our function. Now, there's a very useful thing in C++, which is called inline assembly. Now, Google that these 2 words too. It's called inline assembly. Go Google that. Underscore underscore ASM, and I'm going to open, close, and then inside I'm going to call my function. So the first thing that the argument that the packet takes is a pointer to the packet. So what I'm going to do is basically I'm going to push, and then I'm going to push the length first. So if you look here, the first thing we push becomes the argument 2, not the opposite way. So if we push the 0 first, 0 becomes argument 2, and here it says that. And if the second value push becomes argument 1, and so on. So with that in mind, I'm going to go back to my project, and I'm going to push length, the argument 2, which is the length. Now underneath that, I'm going to move, MOV stands for move, and I'm going to move EAX uh, the word pointer ptr ds, and it's going to be the buffer. That type buffer, right? Yes, I did. And I'm going to move ACX. I'm going to have to include properties here. So go to the top of the document first, include, and we're going to include properties.h, and we're going to type here properties, properties, and we're going to be moving into ECX. We said, yeah, the network class. So network class. Is that how we type that? Now, because it's assembly, it's not going to really let you see that, but yeah, pretty much. I'm just going to make sure it's the right keyword. Yes, network class. Just copy this, and we're going to paste it here. Okay. Now, what we did, push the length, moved into EAX the a pointer to the buffer, and then moved into ECX the network class, and the last thing left is to call and call, and we're going to call but properties send packet original class. So I'm going to do this real quick. Send packet original class, just easier and faster than typing it, and paste that here. So I'm sorry, one thing I forgot to do. This is not going to be moved into EAX. This is going to be pushed into the stack. So push the word ptr ds blah blah blah. So type precisely what I just typed here, and everything should work fine. Now let's try and build our project. We should get no errors. Everything should work fine. No, one thing didn't work fine, and it's the length. So yeah, I can tell why. Because it's defined somewhere else in the project, and it's not really supposed to be that way. So all I gotta do is just move or change this from length to, let's say, underscore length, and then change this into underscore length too. Let's try and build a project now. Okay, voila, everything works fine. Okay, now every time we send a packet to the server, all we gotta do is just call this function send to server, and we pass the buffer that we want to send, and we pass the length of that buffer, and it'll send it to the server, encrypt it, send it, and it comes back. So that's good. So far so good. Now we found the function, we know how to call the function, and the one thing left is to hook that function. So we're going to do that now, and we're going to start with creating a new class. So I'm going to right click, add, and I'm going to add a class. Double click on C++ class, and I'm going to call it hooks. So click finish, it'll generate this class. Now what we're going to do is going to delete this, actually leave this one right here, and we're going to go here and yes, delete these two. Okay, now we're inside hooks.h, and I'm going to change this from void, and I'm going to first thing go and include the files that we need. First thing I'm going to need is the basic functions.h. So I'm going to include, and I'm going to include basic functions, and underneath that I'm going to tell it that we're going to be using the CB client class. So class CB client. It's not really going to show you that, but until you define it, the whole keyword. And underneath this, I'm going to type CB client, and it's going to be called owner. Above it, I'm going to type the following: private, and it's going to be also, no, before it's static, we're going to be using the word static, CB client, and it's going to be called owner. Underneath that, I'm going to, oh my god, my back hurts really bad. So, with that done, let's fix this too. I'm going to go underneath, and I'm going to type this, owner equals owner. So, I'm going to collapse this. Now, one more thing we need to do is, underneath this, we're going to create a void. Void send packet hook, and it's going to be also a void. No, yes, actually, yes. And we're going to have to include, and we're going to include properties.h2. And with that done, I'm going to switch back to, I'm going to copy this first. I'm going to switch back to hooks.cpp. Now, right here, I'm going to paste this, and I'm going to tell it where it's defined, which is going to be in hooks also, right here. So I'm going to type hooks, two of these double dots, and then above it, we defined a CB client, which is called owner. We're going to copy this, go back here because it's static too, and we're going to tell it also where it's defined, and it's defined in the hooks class too. Now, to make sure nothing's going to go wrong, you're going to have to include, and we're going to include the CB client.h. Now, inside this function, this is going to be the function that will be called from the process instead of this address here. So instead of this address, we'll put the address of our own function. So it calls our own function instead of this address. And then our own function is going to call that address in here. So again, we're going to be using the underscore ASM keyword, and inside here we're going to do the following. Go back here, like in this in here, what it does is basically LEA, I mean like shortened for leave, I think, EAX, the value of ESI plus 4, and that will become the pointer to the packet. And then basically what this line does is reads 2 bytes like this from the very first like from the 0 index of that buffer. So basically it's like your packet reader, and it's reading 2 bytes, which is a ushort value or short unsigned short value. So now that we know that, all I gotta do is basically copy these 2 lines like this, paste them here. Before we do that too, before these 2 lines, we're going to type push AD. Now, if you don't understand these assembly instructions, go online and Google, uh, maybe type a list of assembly instructions or stuff like that. It'll pop a lot of results for you. Try Wikipedia maybe or something like that. It'll explain what every function, or maybe, I mean, what every instruction does. Every instruction does something different, and it'll explain what it does for you. This function pushes the registers into the stack and save them, and then when we call pop AD, it'll restore these registers. Not all of the registers, but some of them. Now, with that in mind, all I got to do is now move the length and the pointer and store them somewhere. So I'm going to go back here. Underneath this, I'm going to type static. It has to be static. Don't ask why. Static, and it's going to be an integer, and it's going to be called send packet. No, actually, I'm going to change the word send to outgoing packet length, and I'm going to define another integer, and it's going to be static 2, and it's going to be called outgoing underscore packet underscore pointer. Yeah, that's very convenient. Anyway, copy these two, and we need to tell it where they're defined to. So switch back here, and they're defined inside the hooks class. So with that done, go back here, and we're going to do the following. Now we're going to type MOV, stands for move, and we're going to move into the outgoing packet length. Remember, we said the EAX is the pointer, ECX is the length. So we move ECX into the outgoing packet length. So type ECX. Underneath that, we're going to MOV, and we're going to move into outgoing packet pointer, and we're going to move the value of EAX into it. Now we have what we just did is store the value of ECX into the packet length and the value of EAX into the packet pointer. So with that done, one thing left is to process this packet somewhere. So to do that, I'm going to do the following. I'm going to go back to the cbclient.h, and I'm going underneath this, I'm going to type void, and it's going to be called send packet hook, yes, that will work. Callback, yeah, that sounds good. And it's going to take, we can either pass the arguments such as the, like we're going to call this function from this function here inside the hooks.cpp. We can either pass these two arguments here, or we can use it through the CB client class, because we're going to define this class inside, or use an instance of this class, which is hooks, inside the CB client. So that's what I'll do. I'll leave it without any arguments now. I'm not going to pass anything to it. Go back to client.cpp, cbclient.cpp, paste this, tell it where it's defined again. It's defined as CB client, and in here we will pretty much do nothing for now. Yeah, let's go back to the cbclient.h, and we're going to define one more thing. We're going to include, yes, what am I doing? Okay, include, and we're going to include, honestly I forgot what I'm going to, yeah, hooks.h, so we can use it inside this class. Now we're going to type underneath this, I'm just going to type hooks, and I'm going to call it hooks with a small letter h, not a capital letter H. And I'm going to switch to client.cpp, and I'm going to do the following. I'm going to type hooks without a capital H equals new hooks with a capital H, and this class takes an argument of a CB client. We're going to pass this as a CB client. Now in here, after we define this, all we gotta do is basically create a new TQ packet, or maybe a byte buffer or something similar. So for this demonstration, I'll just use the byte buffer. So I gotta include byte buffer, And right here I'm going to type byte buffer, or I'm going to call it packet equals without this. You can just initialize it without this. And it's we're going to pass an LP void as an address, and an int as an integer as the length. So LP void, and it's going to be hooks without a capital H, and we're going to pass the pointer for the packet. So I'm sorry, I made this private, so we gotta go back here into the hooks.h and make sure this isn't under the private uh, keyword. It should be here. And this also we need to make static, which is the send packet hook. So go back to the client.cpp, cbclient.cpp. Now you see it's not giving me any errors, and I'm going to pass hooks without a capital H, and I'm going to pass the length. So that'll create a byte buffer, a packet for us, and we can read it. Now every time I receive excuse me, every time the client sends a packet, we're going to print it to the client. So print it to the console screen, and we're going to tell it, we're going to say client is sending a packet, and we're going to print type, and it's going to be, we're just going to use integers, not in hex, so we'll just type, oh sorry, and the length, and also it's going to be an integer, so, and we're not going to use it, just going to keep it in decimal, and we're going to pretty much use the packet to read these values. So packet dot read, and we're going to read uint16, which stands for a u short value, or short, and the offset of that is going to be 0, so it reads at the offset 0, and then packet dot read another uint16, and it's going also to be reading it from offset 0. So with that done, let's one more thing left to do. Now let's try and build our project. Hopefully we'll get no errors. Now everything worked just fine. Next thing I'm going to do, which is the main thing, if we don't do it, nothing will happen, which is go into the source files, basic stuff, and we're going to open cbhelper.h. It's already opened, yeah, but whatever. And underneath this, what I'm going to do is, now I know that if it reaches this line here, that it found the address, because if not, it'll just return false and exit the process. So underneath all this crap, I'm just going to do the following. I'm going to go and type ASM patch address right here, and it'll ask you for the destination address, where to write those bytes, and the function that's going to be called instead of the old function, and how many NOPs you want to put after that function. So right before I do this, let's delete this, I'm going to have to create a client. So let's include, and I'm going to include cbclient.h, and underneath, right underneath the create console, I'm going to type the following. CB client, and I'm going to call it client equals new CB client. So now I can go and type ASM patch address, and the address we want to patch, we go switch back to OLE, is this address here, this 6E618A. So right click on this line, edit copy address, or hit Alt Insert and it'll copy it for you. And I'm going to make it C++ friendly and I'm going to paste it. Now next thing, what is the function that you want to call back at that address? The function is client hooks dot send packet hook. Now the last thing is the NOP counts. We don't want to put any NOPs at that address, so I'm just going to hit 0. So I can either keep this address and change it manually every time it changes, or I can simply use the send packet address that we just found to patch that address. So that we know, now that we know, once we found those bytes, the address is going to be right here, 6E617D. All I gotta do is count the number of bytes until this call here, and then place my patch. So I think that's what we're gonna do right now. So let's switch back to Ole. No, before, let's read how many bytes are in here. So 3, 6, 7, 8, 9, 10, 11, 12, 13, 14 bytes. So to patch this address, all I gotta do is tell it 13 byte. So 13 byte, it'll write them at this address right here. So I'm going to switch back and I'm going to replace that address with send packet address right here plus 13. So it'll always count 13 bytes starting from this address, and then it'll place the batch here. So with that done, let's build our project. Hopefully no errors. Build succeeded. Now the only thing left is to test it. So I'm going to reopen this and start a new client. Now I can see it says it's telling me what's the addresses it found, and they look fine to me, so I'll try and log in. If everything goes fine, the process will continue. If something went wrong, it'll crash. So I'll just continue. Again, that annoying message. Let's give it a second, and I'm going to log in. Please log in later. Okay, what about now? Okay, our process crashed. That tells me something went wrong. So let's go and check out what went wrong along these lines. How am I going to do that? I'm going to do that by simply starting the process again. As you can see, it'll be running because we're not sending any packets really. And I'm going to go back to Ole and I'm going to click File, Attach, and I'm going to find Conquer.exe, not the red one because that's the currently attached one, and I'm going to attach to it. Hit Shift F9 to continue. Yes. Model contains corrupted. Okay, that's fine. And wait until it's all the way loaded. And now that's done, I'm going to go View, Executable Models, and I'm going to find our DLL. So it's located in the G drive. There it is. So I'm going to open it, Control A to analyze it. Now I can search for, the easiest thing to find those functions is search for all reference strings, because it's a newly created DLL, not a lot of stuff in it, and it's built in release mode, so I can easily find those strings. Now right here, let's find the one that says program is sending a packet or something like that, or client is sending a packet. Where is it? Send packet address. It's not even there. Anyway, let's just instead search for names, and we can scroll a little down and read all these names until we find the one we're looking for. In our case, we're looking for the send packet hook. So we'll find it sometimes today. There it is. So I'm going to double click on this, and I'm going to place a breakpoint on it right here. Now, I know the reason it crashed, and I'm going to fix it now, but for you to realize that we made a huge mistake and to see what mistake I did is, first thing, I pushed all the data. Let's run the program to make sure that you can see it clearly. Okay, I'm sorry, my bad. I'm going to log in. My breakpoint will be triggered. Now you see our hardware breakpoint were triggered before our breakpoint. So let's hit F7, and if you noticed, now instead of calling that address, it's calling the send packet hook inside our DLL file, which is CB helper. Now hit F7, it'll take us inside that function. Now inside that send packet hook. Now notice what's going to happen on the stack here. Now this is where we are. Now I'm going to hit F8. See how many registers it pushed into the stack? Almost all of them. Not all, but almost. Now it leaves EAX, ESI plus 4, blah blah blah. Now it's this address, which is the outgoing packet length, is 0. It moves the value of ESCX to it. Now if I check it out, it becomes the same value. Now same thing here. It should become the pointer to the packet. Now it returns, but right now it's returning to a perfectly invalid address, because this is the address that it's supposed to return to. Now it's returning to this address here, which will definitely crash the process. The reason is because I didn't finish coding my function. I totally forgot that, which is silly from me. Let's close Ole. Go back to our project and go back to the CB hook, hooks.cpp. Now, it called this function, and so far so good. The only thing that's missing is to call the callback for the send packet function, which is owner, and we're going to call the send packet hook callback. Okay, with that done, one thing left is I'm going to type __ASM to start a new inline assembly structure, and I'm going to type the following. I'm going to pop AD, pop all data, which is what I pushed earlier, and underneath that, the only thing left is to call the original address that we replaced with our own call. So to do that, I'm going to go call, and I'm going to have to include, before I call, I have to include the properties.h. So we can call properties. I can't even type. Fuck. Properties. And if I recall, it was called the original packet, whatever. There it is. Now paste this. It'll call that address. Last thing I need to do is return. So RET stands for return. Now if I try and build this, no errors. Let's go back and try and start our process again. Start. Now I'm going to log in and see what's going to happen. Okay, something happened here. Look, here we go. It says client is sending a packet. Packet type 2040 and the length 2040. That's totally not right. Something went wrong. So let's go and check it out. I really don't know what just happened, but yeah, let's check it out. And we're going to cb client.cpp. Oh, my bad. This is supposed to be 0, and this is supposed to, this is supposed to be 2, and this is supposed to be 0 for the opposite, where it's supposed to read the type and the uh, length. Build this, and still there's something wrong because our process froze. It didn't continue. So let's start Conquer, start only debug, file, attach, and I'm going to attach conquer.exe. Shift F9 to continue. Now I have already a breakpoint. My hardware breakpoint is already set and it's not gone yet, so I'll just leave that as is, and I'm going to try and log in. So that okay. Now my breakpoint is triggered. I'm going to go inside the function and see what's going on in there. So I'm going to hit F7. Now first thing it's doing is pushing EBX, ESI, EDI, and then it's pushing all data. That's not right. Let's hit Control A to analyze this again. Because if you remember, the first thing we did is to push all data. We didn't push EBX, ESI, EDI. So that's totally not right. And to fix this, I'm going to have to go back to our project, and I'm going to hooks.cpp, or yeah. And the one thing we forgot to do is specifically define this as a naked function, which is naked. That's why it created these three pushes and these 3 pops. So I'm going to close this and rebuild our project after I inserted this keyword, which is the naked, and I'm going to run it again. But this time, without attaching to it, I'm just going to log in and hope for the best. Okay, sending a packet. Now we can see the type and we can see the length. So still it's frozen, and we gotta check that out and see what's going on. Sorry, I didn't really mean for this to be that long, but whatever. It is what it is. I could have just used my old code because it works perfectly, but I didn't want to do that. I just wanted to do a fresh thing, go at it from scratch. So now, wait until it's loaded. It is. I'm going to go and find my DLL. No, without finding it, I still have the breakpoint on that thing, so I'll just go ahead and log in. Okay, my breakpoint was triggered. I'm going to hit F7 to go inside the function, and as you can see, all that crap is gone. But what really caused the process to freeze? Let's step into it step by step. First, I'm going to hit my marker here. Right, I'm going to double click on it. It'll set that, and I'm going to hit F8. It'll push all these registers, and I'm going to hit F8, F8. Length is F0, that's okay, and the buffer, that's okay. And it calls this function. Now we need to remember that we're at -20 here. We need to make sure that when this call returns, the stack is still the same. So hit F8, it's the same. Now it pops all of this. Now it calls the address of this function, which is the send packet crap. Now let's call this, and the process froze. Now the process froze for a reason, which is I didn't pop the return address. So I needed to pop the return address for that function before I call this. So what we're going to do is close this right here, and we're going to switch back to our project, and we're going to have to go back to hooks.h, and we're going to define one more thing, and this is going to be called first a static, yes, and it's going to be an integer, and it's going to be called outgoing packet return address. Perfect. Now copy this, switch back to hooks.cpp, do pretty much the same thing we did earlier, make it understand where it's defined, and then we're going to copy this like this. Before we push all data, we're going to go do the following. Pop, and we're going to pop the outgoing packet return address, and then before we return here, we're going to push outgoing return address, so it returns to that address. So now build this and close this. Now we're going to try and start our game again, and hopefully this time it'll work. And I'm going to try and log in, switch back to the console screen. There you go. That's how it's done. 1 second, what the fuck just happened? Okay, there it is. Now, if you look here, every time a packet is sent, I have access to it. I have the length, and I have the type, and I have the whole packet buffer. So if I go back to the game, let's try and walk for a long distance and see what's going to happen. Switch back here. 1 packet for each block. Again, 1 packet for each block, which is 1,000, 10,005 or something like that, whatever. Now, if I, let's say, use the shield block skill, switch back, packet 1022. And pretty much that's it for this tutorial, and I'm sorry it was a very long tutorial, and I hope it helped you and that you found it useful and I didn't waste my time for nothing. So until the next tutorial, be safe.